Okay, folks. So there's only actually two units here, and now it's looking into using those same basic principles, like how to solve a single triangle. At this point, you should be good with Pythagoras, using two sides to solve a third side. But you should also be able to use an angle to find side or an angle as well, or to just find angles in general. So now is when we sometimes have to break problems down into two or more triangles and work in steps to solve it. I need A to get B to get C, right? I need to make the dough to put on the pan to add the cheese to make the pizza. It's a step-by-step process now at this point. And there's no real like formula to it. It requires you to really sit down and think, how do I solve this question? And oftentimes you need to figure out like what you have to solve what you don't. So you usually have to start with one direction and then make your way to the other direction, if that makes sense. This is a tricky unit. You are not dumb if you're struggling with questions. They are hard. This is the hardest unit in the entire course. So this is why you're being given so long, mostly to give you a buffer zone to, oh crap, I have no idea what I'm doing, and to ask for help, okay? Um, so usually what you want us to start thinking about here is, what do I have? Specifically, I want two things, right? I need to have two things to find a third. That's how this entire course works. I need two things to find my third thing. It's that simple. So let's starting with this one here. It wants us to find both x and y. Read the questions carefully. Some of them ask you to find as many as three or four things. This is also where circling your answer and organizing your work is going to come in handy for this one as well. All right. So the first thing here is I want to find x and y. Now, if I look at y, all I have is an angle. I don't have any sides of this triangle here, right? So I can't use that. Doesn't work. So instead, I'm going to use x, and I'm going to use this other triangle here. So I'm trying to find x here is what I'm going to try and do. Now, I know that this is my opposite side. This is my hypotenuse, which is x. And then this is my adjacent side. So I have something with an A, and I'm trying to find the H, AH. SOHCAHTOA, right? You're gonna be writing that down a lot. What has A and what has H? Cosine. So the cosine of 40 degrees is equal to adjacent, which is 6.4, over hypotenuse, which I could put X, I could put H. I'm just gonna put X. Doesn't matter. It's the same thing. Don't let the numbers scare you, or the letters scare you. Now, first thing I need to do is I need to times both sides by X. Times by X. I know that sounds kind of weird to do that. I'm doing this to both sides, by the way. I'm just writing it over here for space. Actually, I'm going to write it over here for space. So I'm timesing both sides by X. On the left side, I'm going to have X times cos of 40 is equal to 6.4. In fact, no, I'm going to keep it. It's cos of 40 times x is equal to 6.4. Now I need to get rid of this cosine of 40, so I'm going to divide both sides by it in this case. So now I'm going to divide both sides by cosine of 40. Because remember, that has a value, right? That's going to be like 0.5 or something like that. So if I do that, I'll be left with x is equal to 6.4 divided by cosine of 40. And you can put it as a fraction. In fact, I'm going to do that. It's always a good habit to stick stuff in fractions if you can. I'm not typing well today. My office is cold. All right, so now all I gotta do is plug it in my calculator. Come on. So it's 6.4 over cosine of 40. 8.35. We're going to stick with that. We're going to stick with 8.35. So in this case, x is equal to 8.35 meters. Perfect. And I'm actually going to write that in here. So 8.35 meters in there. Okay, perfect. So I've done X, check. Now I want to look at Y. Now for Y, now I do have something. Now I have an angle and I have a side. I have two things in this triangle because this is a shared border. This is going to be a very common trope you're going to see in a lot of these questions. So now I'm going to do Y. Now for Y, I'm running out of space here, but for Y, I can see I have hypotenuse. Sorry, I have, this is my opposite side for this one. Even though it's hypotenuse for this triangle, for this other triangle is my opposite. This is my hypotenuse. And I'm trying to find Y, which is my adjacent side. So OA, that's TOA. So TOA of 68 is equal to the opposite, which is 8.35 divided by the adjacent, which is Y. So I do it the exact same way, just for the sake, I don't have a lot of space left. I'm just going to kind of skip this step, right? I know I need to times by Y, right? Times by Y. And then I need to divide by TOA of 68. That's what has to happen here. And if I do that, I should get Y is equal to 8.35 divided by TOA of 68, right? Oh, sorry, why am I putting TOA? It's tan. My bad, guys. 3.37. 3.37 meters. Now again, good habit to get into. Circle your answer, highlight it, do a something. Keep your stuff organized. I don't have a lot of space. I don't like organizing my work like this. It's very messy, right? It's very, like, look at how much is on the screen. If you weren't following along, you have no idea what's going on, right? We don't want that. So you got to keep organized as best you can. I'm working with finite space and on a computer. You guys have a little bit more flexibility there. So now for this one here, I actually want you to try this. Think about, don't even try and solve it. Think about what you would do to solve it, right? And to give you an idea here, you don't have to do this every time, but I'm going to label each side. 1, 2, 3, 4, 5. And I want you to think about, like, I'm going to use the angle and side 2 to find side 3, something like that. So just give yourself 30 seconds, pause the video, figure out how you're going to do it. 3, 2, 1. So this one's kind of a tricky question, right? Like, how am I going to do this? How does this possibly work? Well, we have a couple of options here. But we always start with, what do we have? And now I'm going to give you guys a little bit of a hint here. How many degrees are in a triangle? A triangle has 180 degrees, right? So a triangle has 180 degrees. Now I know that this triangle has 37 degrees. I know that this triangle also has 90 degrees. I'm looking at the whole triangle here. If you can see how my mouse is moving. Which would mean, that's 127, which means the other angle here would be 53 degrees. So this angle here is actually 53 degrees. A little bit smaller here. So that might come in handy here, because now I could find, there's a couple ways to do this. One way is I could use this 37 and this 4.9 to find the length of side 1 here. Then I have two sides. I can use it to find the entirety of the big side. And then I can just take away this side. So that's one way to do it. There are multiple ways. I think I'm going to progress with that way, though. And it's funny enough, actually, if you were to even take this picture and throw it into like an AI or something, it would probably not be able to do it. Like, people are like, oh, ChatGPT, it's so good. No, it's garbage at math. Like, just trust me, not good at all. Here, so let's erase all this crap and let's actually start with that. So we're gonna do that plan. So I know this angle is 53 and I know this one's 37. I'm going to find, I'm going to use that to find side A. I'm going to call this side A. So to find side A, I have an angle and I have a side. So this is my opposite side. 4.9 is my opposite. This is my hypotenuse, the entirety of this line, and then this is my, well, adjacent. So it's A, so whatever. So I have O, I'm trying to find A, tan, right? So tangent of 37 is equal to 4.9 over, let's leave it as A, sure, why not? Right, then I times it by, then I times by A, so then I get tangent of 37 times A is equal to 4.9, right? We've done this before. Then I divide by tangent of 37, and I get A is equal to 4.9 divided by tangent of 37, right? Just like that, just how we've always done it. 4.9 divided by tangent of 37, 6.5. So equals 6.5 meters here. I'm going to underline that, or you can circle it, box it, that's important. But either way, I'm going to right now actually put that in my triangle. So now what I have here is I have two sides of a triangle, and now I can find the entirety of the third side, which I'm going to call B. B is all of this, okay? So now for B, this I'm trying to find the hypotenuse. That's my C squared, which means the other ones is B is A and B. 4.9 plus 6.5 is equal to C squared. I realize I've made a mistake by labeling these B and A. It might make it more unnecessarily confusing for you, and I do apologize. When I'm talking about B, I'm talking about, I'll even highlight it here. I'm talking about this line, right? Which is also C if I look at the actual formula. So my bad. These are the same thing in this case, okay? All right. So, right, this is a pretty simple application of it. So it's 4.9 squared plus 6.5 squared is equal to C squared. 4.9 squared plus 6.5 squared is equal to 1,014. And you know what? We're just going to do this. We're just done. 31.85. Let's just go 31. I don't care if you put 0.9 or 0.8 here. I don't care. If you've done it at this point, you know what the heck you're doing. So this is C, right? This is just C. I don't have a lot of space. That's why I'm doing this. So boom. Sorry, which is C, which is also B. Like I said, my bad, guys. So this entire thing here is 31.9. Now, all I need to do is take 31.9, figure out what the heck this part is, and I can take that away, right? That's how that can work. Sorry. Let me reword that. Oop. I can take 31.9, which is the whole thing, and take away this part of it. I have no way to find x directly. This is not a right triangle here. I don't know how to work with non-right triangle. Well, actually, no, it is a right triangle. Again, there's more ways, right? Even I make mistakes like, oh, wow, I have overly complicated this, guys. My bad. I'm still sticking with my original plan. Again, multiple ways. I've gone a slightly harder way to do it. I'm going to call this thing over here C. So I'm going to find this. So to find C, I have an angle. I have, this is my opposite. This is my hypotenuse. This is my adjacent. I have hypotenuse and I have adjacent. Cosine. Cosine of 53 is equal to adjacent, which is what I'm trying to find. I'm going to put C. All divided by 4.9. Right? And then it's just cosine of 53 times 4.9 is equal to C. Cosine of 53 times 4.9 is 2.95. 2.9. Sure. Again, rounding isn't the thing here. If you've gotten to this point, you know what the heck you're doing, and I'm going to keep track of that. So I'm going to underline that. Perfect. That's important. So now to actually find x, all I got to do is take my 31.9 and subtract my 2.9, and I will get 29 meters. So I was just looking at this and I realized I made a mistake. I accidentally timed these ones up here. My bad, guys. I've ruined this question a lot for you. So this one here, I put like 31.9. No, this adds up to 66. And then if I square root that, it actually should be 8.14. So this is supposed to be 8.14 here. And then I'm supposed to do 8 point, I'll just do 8.1 here. 8.1 minus 2.9 would give me 6.15.2 is the actual answer here. Again, my bad. All right. So let's move away from that question here. Before we keep going, though, at some point, you're going to have to make use of other angles here. I actually want you to go up here. I'm just on the side. I want you to write something. A triangle has 180 degrees, right? A square or a rectangle has 360 degrees. A straight line has 180. A right angle has 90. These are going to come into play. For example, if I give you a line that looks like this, let me actually use straight lines here. If I give you a line that looks like this, here we go. And I'm like, hey, this entire angle here is 150 degrees. Well, there's a secret little square here, right? This is a square line. So to find this angle, well, it's 150 minus 90. That means this part of it would be 60. You're going to see stuff like that through here, okay? All right, so get that down. I'm moving on in 3 seconds, 2, 1. All right. So this one here, question 2. How would you solve this? I want you to think about this. Again, literally sit down, put your pen down, look at it. How would I approach this question? Well, this one has a pretty obvious approach to it. Well, I have two sides for this left triangle here. Why don't I use side 1 and side 2 to find side 3? And then I can use my angle on side 3 to find y. Yeah, exactly, right? So we're going to start with finding x. So to find x, I'm using two sides to find a third side. That's Pythagoras, right? And I'm trying to find my hypotenuse, which is my c. So that means I can just do it's 9.4 squared plus 8.6 squared is equal to, I'm just going to put x. I'll keep it consistent, c squared. Make sure we add it this time. That's my bad. Right? So 9.4 squared plus 8.6 squared. That's the train. You can probably hear that. 162.32. 162.32 is equal to c squared. So then all I got to do is take the square root of it, right? Square root of that, 12.7. Good enough. 12.7 centimeters is our C. Underline that because that's important. That's this thing here. I'm going to label that in here. 12.7. A little smaller for you guys. All right. So now to find my y, well, to find my y here, I have an opposite side, I have my hypotenuse, and I have my adjacent. I'm using A to try and find H. So toa. Cosine, right? So cosine of 48 is equal to adjacent, which is my 12.7, divided by my hypotenuse, which is my y. Right? And then it's just like before, right? I'll get cos of 48 times y is equal to 12.7. I just times both sides by y. And then I need to divide by cos of 48. So y is going to be equal to 12.7 divided by cosine of 48. And I'll get 18 point. We're just going to go to 19 in that case. That's basically 19. So y equals 19 centimeters. So those are both final answers. So I'm going to circle both of those, right? At this point, I trust you guys to be able to find something like this. This is obviously a right triangle up here as well at the top. So I trust you guys to be able to do that. This one's kind of tricky. Again, though, I trust you guys should be able to potentially do this. If you're not sure, just ask. Now, for our next example here, we have a flagpole that is supported by two wires that are each attached to a peg 4 meters from the base of the pole. So that's right here, 4 meters from the base of the pole. The wires have angles of elevations of 35, which is this one, and 45, which is this one. I'm going to call this angle A. Oh, no, we're already using A. I'm going to call this one angle M, and I'm going to call this one angle N. So question one, how much higher up is the flag? How much higher up the flagpole? How much higher up the flagpole is the top guy wire attached? Wow, English. How much higher up the flagpole is the top guy wire attached? So in that case, it's probably asking us to find Y in this incident, right? Whereas with question B, it's asking us to find B and A. So let's start going through this. Now, for question A here, I'm going to use my space. Sorry, how much higher up is it? So I have to take I have to take Y and subtract X, right? So let's find Y. Now, so that means I'm going to use my N angle, right? 45 degrees. So I'm trying to find the opposite, and I have the adjacent. Opposite, adjacent, opposite, adjacent. Tangent of 45 is equal to my opposite, which is what I'm trying to find, divided by my adjacent, which is 4, right? And then it's just tangent of 45 times 4 is equal to Y. What? To make sure I got that right. Yes. Okay. So that gives us a nice easy answer where Y is literally equal to 4. So 4 equals Y. The length of the Y is 4. I'm not done the question though, because it asks us how much higher up the flagpole is the top guy wire attached. This is a poorly worded question. It should be from the bottom wire, right? It wants us just to measure this highlighted distance here. So if all of it's 4, now I got to take away X. So now I got to find X. And it's done the exact same way, right? I'm trying to find the opposite. I have the adjacent, and I have an angle. Tan of 35 is equal to X over 4. Oh, what did I just do? Oops. And it's done the same way, right? I just bring that 4 over, times both sides by 4, go to X. Now, if I've done this right, obviously it's going to be a shorter height, right? If I get a bigger number here, I've messed something up. So tangent of 35 times 4, 2.8. So 2.8 is equal to X. I'm not done though, because it wants us to find how much higher up. It's literally 4 minus 2.8 gives me 1.2 meters, right? So blah, 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 blah. The flagpole is 1.2 meters higher. Perfect. Okay, question A, done. Now I want us to find how long is each guy wire, which is A and B here. Well, we can do that. I have two sides. I have 4. So I need to use Pythagoras twice here. Technically, you could use trig too. I want to use well. Do I want to? You know what? You could use Pythagoras because you have two sides, trying to find a third side, or you could use trig because you have two things you're trying to find a third thing. I don't care which you pick. I'm going to use Pythagoras because this is meant to be an example and give you some guys some exposure. So question B, we're going to try and find A. Now for A here, that's A squared plus B squared plus C squared. The A is my C in this case. It's the hypotenuse, right? So that means it's 4 meters squared plus, I said X was 2.8 meters squared is equal to C squared. Right? So 4 squared, which is 16, plus 2.8 squared, going to give me 23.84. So 23.84 is equal to C squared. Then all I got to do is take the square root of that, right? And I should get 4. We're going to say 4.9. 4.9 is equal to C. So, and that is this in this case, right? So this is 4.9. But it says A over here. Yes, you're right, but we use C to represent the hypotenuse in Pythagoras. So this is, so, it's equal to A as well. I know that's a little confusion, and I do apologize. That's just how math works sometimes. Then we do the same thing for B, right? So for B, it's the same thing, right? I'm still using that 4 squared. I'm still trying to find the hypotenuse. So it's 4 plus 4 squared is equal to C squared. 4 squared is 16, right? 4 times 4 is 16. So I'm adding 16 plus 16 is 32. 32 is equal to C squared. All I got to do is take the square roots of 32. Can't do it this way. Breaks the calculator. Got to have that square root symbol at the front. Is equal to 5.7. Sure, why not? So 5.7 is equal to C in this case, which is actually B. Circle that. That's also a final answer here. So this asks you to find 3 things throughout these 2 questions. But so again, this is the level of like sophistication here. You have to use what you know to find what you don't know, and then use that in a problem. Okay, so it's 2 or 3 steps. So it's a lot. Do I want to do this one? How tall is the second? Yes, I do. You know what? Because this one doesn't label stuff. So this is where you usually want to actually go in and label stuff yourself. So from the top of a 200-meter building, the angle of elevation to the top of another building is 40 degrees. They angle that. And the angle of depression from the bottom of the second building is 25, right? Again, angle of elevation, I'm looking up. I'm happy. Angle of depression, oh, I'm sad. So that's where we get these 2 angles from. It wants us to find how tall is the second building. What am I trying to find here? It doesn't give me an x. I'm trying to find the length of this line. How can I possibly do that? Well, I could find, if I label this x and y, just add those up, right? Because I have 2 triangles that I can work with here. So that's one way to do it. There's multiple ways, guys. That's one way to do it, which that's going to be the way I'm going to do it. Now, kind of a tricky thing to be able to do, though, right? Like, okay, but like I only have an angle for this triangle and this triangle. For this triangle, I know how tall the building is, but like that's it. Well, if this is 200 meters, that means y is 200 meters, right? So all I really care about at this point is finding x. And now for this triangle, which I'm going to call triangle 1, I'm going to call this one triangle 2. For triangle 1, I now have an angle and I have a side. I can now use that to find something to give me something to find x, right? In which case, what's the border they share? They share this green line here. I'm going to use 25 and 200, 25 degrees and 200 to find the green line. So for triangle 1, right? I have an opposite side. I'm trying to find the adjacent side, and there's a hypotenuse. I'm using O to find A. O to find A. Tangent of 25 is equal to O, which is 200, divided by A, which is, I don't know what the heck it is. Right? We've done this a ton of times before. Times both sides by A. I get tangent of 25 times A is equal to 200. Divide both sides by tangent of 25, and I'll get A is equal to 200 divided by tangent of 25. Again, we've done this a bunch of times before. 428.9. So A is equal to 428.9 meters in this case. Underline that. Label it. Go in, label it. 428.9. That's a little bit smaller for you guys. Move it over here. Perfect. All right. Now for triangle 2, I now have a side and I have an angle and I have a target. So I'm trying to find my opposite. This is my hypotenuse, which is useless to me, and I have an adjacent. OA, it's tangent again. Tangent of 40 degrees is equal to my opposite, which is what I'm trying to find, x divided by my adjacent, which is 428.9. So times both sides by 428.9, tangent of 40 times 428.9 is equal to my answer in this case. Should get 359.9. 359.9 meters. Right? That's this one here. So cool. The answer is 359.9. No, it's not. I need to add up this 200 and 358.9. Don't do all this work to forget what the question's actually asking you. 200 plus 259 is equal to 559.9 meters, which is the total height of the building. Again, there's other ways you could have done this. This is just the way I have personally chosen to do it. If you didn't realize, for example, that this is 200 meters, you could have used this 200. Now, you could have used this 200, and you could have also realized that, oh, this is a right angle. If this part's 25, that means this part must be 65. And you could have used that to find out the length of your hypotenuse, which then gives you 25 and your hypotenuse to find this side. More work, but it's doable. So there's multiple ways forward, guys. Some are a little bit more work than others, but at the end of the day, they're going to give you a solution. Okay. I'm going to trust you guys to be able to do this. If you're not, you get 2 weeks. Ask me for help. We're going to go to our next one here. Now, everything we've been doing here has been involving like 2D triangles, but what happens if I go to a third dimension? If you look at example 3 here on page 221, you see that here. So in this case, if I have you like just a square box, right? Think like you order something from Amazon. They can put it in diagonal to extend it. If you've ever had to move anything like a bed into a room, for example, you've probably done the same, right? Sometimes you got to pivot it a little. Excuse me. Sometimes you have to pivot it a little bit. So we see here we have a box that's 10 by 12 by 15. And we want to know what's the longest rod that can be carried in. This is something that things like Amazon, Canada Post, UPS, they all do. They have to have the math on this. They have to know exactly if you have something this big, it goes in this package. They have formulas and they have preset choices that their representatives have to make. So this one asks here 2 questions. One, what is the length of the longest rod? Sorry. Allergies. And 2, what angle does it make with the bottom? So it's asking us to 1, find the length of the rod, and 2, find the angle. Now, as you can see from this diagram, and this is why drawing a diagram for any word problem is huge, there's actually a little triangle here. If I were to take this triangle, which I'm going to highlight in green, and if I were to just spread that up, actually, let's just stand it up here properly. Let's look at it from an overhead view. This is what we get. This one's 15. This one's 12. Here's that. And I'll turn it. So in fact, I'm going to keep this one green here just for that sake. But now what happens if I go to a purple one here? There's also another triangle, which if I look from the side, is going to look just pretty similar. So these are where our secrets kind of lie here. I don't know how big this is. This is D. This one's 10. And then this is L. That's a little L there. So these are going to be our secrets here to be able to actually answer this thing. Oh, my allergies. Sorry, folks. Now, sometimes we're at a point where I don't know how to solve this. What can I do? Just start solving stuff. If you can solve something, solve it. It's probably going to be the answer, right? So for example here, I know that I need to find D probably at some point. They share the frickin' side, right? And I need D to be able to actually answer this triangle up here. So let's just do that. So starting out here, to find D, here it is. It's a little bit smaller too. Here we go. So to find D, I'm using this green triangle above. I have two sides, trying to find a third side. Ding, 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 ding. Pythagoras. A squared is equal to b squared plus c squared. My hypotenuse is my d in this case, which means this can be my a and this can be my b. And again, c is equal to d in this case, right? I know that's really confusing for Pythagoras. That's just what it is. We got to deal with it. So 15 squared plus 12 squared should give us like 300 something, 369. So 369 is equal to c squared. If I take the square root of that, it's going to give me, I don't even know what, 19.2. All right, so 19.2 is equal to c, which is the same thing as d, right? So let's label that in here. So this is 19.2. This is 19.2. This is 19.2. So we see how that's really helpful there? So now all of a sudden, I now have two sides, and I can find for sure, I can for sure now find the third side, L. I can do that. I also have two things in a triangle. I can now use two sides. I can use those to find an angle as well. So let's start with L, right? Pythagoras. L is going to be my C in this case. It's the hypotenuse. So I'm going to say 19.2. So L, 19.2 is my A, plus 10 squared is my B, is equal to C squared, which is my L. Oh, excuse me. All right, so now all I have to do is just times it out, right? 19.2 squared plus 10 squared, which is just going to be 100. 468.864. 468.64. 468.64. Double check. Yes. Is equal to c squared. I need to, of course, square root that whole damn thing. 21.6. 21.6 is equal to C, which is equal to L in this case. Right? Label that in there. 21.6. 21.6. That's also conveniently the answer to question 1. Check. Okay, 21.6. So I'm going to circle that. So now I'm trying to find this angle here. And I have three sides to pick from. I'm just going to use opposite and adjacent. Here's my opposite. Here's my adjacent. So I'm using opposite and adjacent. That's that's tan of the angle is equal to opposite, which is 10, divided by adjacent, which is 19.2. Now, we haven't looked at this for a while. It's been a couple days at this point for sure. This was at the very, very start of 4.1. And this is at unit 1, I think, module 1. So it's been a while. Now, I need to get rid of this tangent, right? This needs to go away. But I can't just divide something by tangent. You know, we've gone over this again. I take 10, I take 19.2. I can't divide this by tangent. It breaks the calculator. So you have to trick your calculator into dividing by tangent. So instead, I'm going to take the second function of tangent, the inverse of tangent, that little -1 there. And I'm going to take the inverse of the fraction. And that's going to give me the angle. 27.5 degrees. So theta, the angle, is equal to 27.5 degrees. Awesome. Yeah, let's try question 9 here. I'm gonna trust you guys to do these ones here. Trust you to do question 8. I want to do question 9. Last one, and I think that's it. I think that is it before you get going. Okay, so now for this one here, we have two triangles just like before, right? We have two people. They both spot a nest at the top of the tree. Matthew is 89 meters, and the angle between Sylvie's line of sight and Matthew is 73 degrees. That's this one. And then the angle of elevation from Sylvie to the top of the tree, right? Looking up, elevates, is 35. So what's it asking us? The height of the nest. So what am I trying to find? This thing. I'm trying to find, I'm going to call it H. So in order to do that, I need to either get, I'm going to highlight it. I have a couple options. I need to either get this line, this green line, because then Sylvie has something to be able to use. Um, or I need to get this line so that Sylvie has something to be able to use. Now, obviously, this is the easiest one. This is the shared one between the triangles. And I can see in Matthew's triangle here, I have two things to work with. I have an angle and I have a side. This is my opposite side. This is my hypotenuse side. And this is my adjacent side. So I have an O and I'm trying to find an H. So, ka, toa, sine. So let's start here. In fact, I'm going to actually label these triangles again. Good habit to get into. So triangle one, I'm using sine because it's so, O and H, of 73 is equal to 89, which is my opposite, divided by my hypotenuse, which is, I'm just going to leave it as H. I don't know what that is. That's what I'm trying to find. Right? And then we've done this a billion times. I'm not going to walk through the process at this point. Divide times both sides by H. Divide both sides by sine of 73. Equals 89 divided by sine of 73. If I do that, it's going to pop out the length there. So 89 divided by sine of 73, 93. I'm just going to put 93. So 8, so my hypotenuse, H, is, what did I say? 93. 93 meters. Perfect. I'm going to underline that. That's important. It's not the answer, but it's important. I'm going to label that in my graph. Good habits to get into. 93. So now, Sylvie, I have an angle, I have a side, and I'm trying to find a third side. I have two things trying to find a third. Boom, trig, there's using angles. Let's do it. All right, so now triangle two. I'm trying to find I know it says H here, that's the height of the tree, but I'm trying to find the opposite side of this triangle, and I'm using the adjacent side, right? Remember, these labels were relevant to triangle one before, but now I'm doing triangle two. It's its own different thing. It has its own different labels. Just because this line, the green line, was the hypotenuse for triangle one, does not mean it's the hypotenuse for triangle two. So triangle two, I'm trying to find O, and I have an H. Oh, so sine. So sine of 35, I'm trying to find O, and I have an H, which is 93. All right. Again, just like before, times both sides by 93. So sine of 35 times 93 is equal to my O in this case, which should give me 53.3 meters. 53.3 meters is equal to O, which is my final answer. That is the height of the tree. And you'd want to like write something in there. It's like blah, 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 blah. The height of the tree is blah, 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 blah. You just want to do something like that. Okay. All right. So at this point, I feel confident that you guys should be able to solve all of these. They're kind of tricky. One thing I want to note is that for this one here, I'm going to give you a hint here. Split it up. Oh, I now have two right triangles. So, maybe do something like that. Each of these is 2 feet. So all of this, for example, might be 8 feet. For this one here, draw yourself a building. Angle of elevation looking up is 41 degrees. As a hint there. Angle of depression. Oh, I'm sad. I'm looking down. Now I think, yeah, I think I said you can skip this one if I recall. So you don't have to worry about that. So just make sure you do that. For the chapter test, I think you guys should be good to go for all of these. The only thing to note is, remember that line stuff we talked about way at the start. What about angles? My God, we read a lot. On page 214, I had you guys write this. Like, for example, this is 150 degrees. This one's a right angle here. That means this one's 60. We see that again here. For in the chapter test and for question 3, for example. So again, boom, 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 straight line. This one's 180. Do, 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 do. This one's 90. This one's 90. Well, if all of this is 205, this is 90, this is 90. 205 minus 90 gives you the angle that you need, right? So there's a hint you kind of have. It's a compound shape. You might have to split it up a little bit. I trust you guys. You can do it. For these one here, again, these are parallel lines. That means if this is 62, this one's 62. If this one's 50, there's one dash. That means this one's 50, one dash. Um, this is saying this entire angle here is 74. If the entire angle is 74, well, these are equal triangles. Split it in half. That means this one's 40 and this one's 40, for example, if this one's 80. Yeah, you guys should be good to go for all of this. So great work. And yeah, do your best. You're given 2 weeks for this unit. Ask for help. Do it early. I'm happy to help you out. These are hard questions. You are not stupid if you're struggling with them. They are hard questions. I myself have made mistakes or done unoptimal ways. You've seen it. So don't worry about it.